which will going to be determined either whether it is a true or false will be considered as a logical statement or a truth function. Switching in a sense that is related to Boolean. If it is Boolean, that is zeros and ones. When I am talking about this NOT gate, so this will going to take only one input signal and produces only one output signal. Any one of the input signal is high, then the output will be high because we are performing Boolean addition. Hello everybody, a warm welcome to one and all. Welcome to the first session on chapter 2, that is Boolean Algebra. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. So in our today's session, we are going to learn about this Boolean Algebra. That means I will be discussing about the introduction part of this Boolean Algebra chapter, and also we are going to learn with what do you mean by logic operators and what are the logic operators that we have in a Boolean Algebra, how it will going to be work, everything that I am going to discuss, and we are going to evaluate the Boolean expression using truth table, and also we will be dealing with a logic gate. So these are the topics that I am going to cover in my today's session. So as we all know that computer understands zeros and ones. So for us zeros and ones are nothing, but when it comes to the computer, zeros and ones are everything. So why I am saying this? Because whatever the commands that we are going to give to the computer in order to get done our work, so computer will going to understand only zeros and ones. Whatever the commands that we are going to give, everything needs to be converted into zeros and ones. So when we are dealing with that kind of zeros and ones, then we are going to call that as a Boolean algebra. So this will going to deals with a binary number system that is called as Boolean algebra. So we know about the number system, right? So when we are dealing with the numbers, so if we are representing any data with the numbers, then we are going to consider that as a number system. So based on its base or a radix, we are going to have a different kinds of number system. Under that we have a binary number system that will going to deals with zeros and ones. So when this algebra which will going to deals with a binary number system, that is zeros and ones, will be considered as what? Boolean algebra. So mainly this will be very powerful tool in order to designing a logical circuits which is used by the processor of a computer system. So we are going to use this binary number system or a Boolean algebra concepts in order to design a logic circuits that will going to work with the zeros and ones only. It will take the input as a zeros and ones and it will produce the output as a zeros and ones. So for that purpose, in order to build or in order to design this processor of a computer system, we are going to use this Boolean algebra concept. So these logic gates are building blocks of all the circuits in a computer. We are going to use this logic gates in order to build a circuits in a computer system, and it will going to deal with zeros and ones. So here you can see that he is the George Boole, and this Boolean algebra has been derived its name from the mathematician George Boole. So he was in the year between 1815 to 1864 and who is considered as the father of symbolic logic. So father of symbolic logic is George Boole, and this symbolic logic is also what? Boolean algebra. And dear student, remember this Boolean algebra will going to deal with a two values, that is true and false. So if I say true, that is 1. If I say false, that is 0. So if it is false, that will be low signal or a low circuit value, and if it is true, that will be one high signal value. So that it is also considered as a switching algebra. Very, very important question. What is the another name for this Boolean algebra? It is considered as switching algebra or symbol logic. So this is the introduction part of this chapter. We'll see the next part, that is binary valued quantities, variable and constants. So what do you mean by variable here? What do you mean by constant with respect to Boolean algebra? So that a variable used in Boolean algebra or Boolean equation can have only two variables. What are the two variables it will going to include? One is false and another one is true. So if it is 0, as I told, it will be false. If it is 1, that is true. So if a variable value which is dealing with only two values, one is 0 and another one is 1. So that a sentence which can be determined to be true or false are called logical statement or truth function, and the result true or false is called truth value. Very, very important question for 1 mark. So what do you mean by truth value? Most frequently asked question nowadays. What do you mean by truth values, and what is the alternative name for this? Boolean algebra. So that here if a sentence can able to have zeros and ones as a resultant, or if you are going to use some of the sentence or an expression which will going to be determined either whether it is a true or false, will be considered as a logical statement or a truth function. So that if the results are true or false, then that value will be considered as what? Truth value. That variable which will going to deals with either zeros or ones, that is true or false, then that kind of variables will be considered as a truth values. Next we'll see about the truth table. So what do you mean by truth table here? So if I say logic circuits or if I say logical symbol, everything will going to be based on the truth table. Then what do you mean by this truth table here? It is a mathematical table which is going to be used in order to represent the Boolean expression of logic gate function. So whatever the function which will going to be performed by this logic gate, that will going to be expressed in the terms of Boolean expression. So in order to represent that Boolean expression, if I am using any of the mathematical table, that table will be considered as a truth table. So that a truth table is a table whose column are statements and whose rows are possible scenario. So if you see here, these are the statement, these rows will be considered as the scenarios here. So if a result of any logical statements or expression is always true or 1, then that will be called as tautology. Very, very important question for 1 and 2 mark. What do you mean by tautology and fallacy? So if you see this truth table here, if I am getting all the resultant as 1 always, so whatever the application I am going to perform, for example, whether I am doing addition, subtraction, multiplication, so for all the expression or for all the any logical statement, if I am getting a truth value for all the scenario, then that will be considered as what? Tautology. So if the result of any logical statements or expression is always false or 0, then that will be considered as fallacy. That is the definition of this tautology as well as the fallacy. So here you can see one of the example here. I have 2 values or 2 variables, I can say A and B, right? 00, 11, 01, 01. So you just imagine I am performing the multiplication operation here. Okay, 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So what it means? If it is getting the values always 0, then it will be considered as what? Fallacy. So if I am getting the resultant as always true or a 1, that will be considered as what? Tautology. So we are going to call this representation of any of the Boolean expression in a mathematical table, that will be considered as what? Truth values or a truth table, that will going to deal only with zeros and ones. We'll see the next topic, that is related to logical operators. So as we all know that operators will going to be symbols and that will going to represent some of the operations. So what are the operators that we have in a Boolean algebra? We'll see now. So there are 3 logical operator. One is not, or, and. So we are going to have or, and as well as not operators as a logical operator in the Boolean algebra. So we are going to use these operator in the construction of computer. So that will be considered as what? Switching circuits. Switching in a sense that is related to Boolean. If it is Boolean, that is zeros and ones. So how many operators, logical operators that we have with respect to Boolean algebra? And, or, and not. We'll see the first type, that is related to not operator. What kind of questions that you can expect from these kind of topics? Not in the sense what, then you can expect a question like write the Venn diagram of not, or write the truth table of this not, or write the logical symbol of not. So we'll see now. So this not operator is a unary operator. That operator operates on a single variable. So it will going to operate on a single variable. That variable can hold either 0 or 1. So the operation performed by NOT operation is called complementation. So complementation in the sense what? If I am going to give 0 as my value, the output will be 1. If my input is 1, the output will be 0. That is what complementation. It will going to be just a reverse of input. The output will be just a reverse or a complemented of input. So that the symbol that we are going to use for this NOT gate is bar. For example, if my input is x, then the output will be x bar or x complement. That you have to understand here. So that means x means complementation of x. So if the x my input, x bar or complementation of x will be the output. So you can see here, so if x is equal to 1, then what will be the output? So then x become 0. So if my x is equal to 1, then the output will be 1. Okay. This is how this NOT operator works. So here you can see the truth table and Venn diagram of this NOT operator here. So what is the truth table? It will going to deal with only one variable. One is input and another one is output. If my input is 1, the output will be 0. If my input is 0, output will be 1. How we are going to write a Venn diagram? So if you consider this as a input called x, then it will just a reverse of the input. So it will be x bar. This is the Venn diagram of this NOT operator. Let's see the next operator, that is with respect to OR. So this OR operator is also a binary operator and it will going to operate on the two variables. When it is a binary, it will be deals with two operators or two variables and it will going to perform the operation called logical addition. So when it comes to the NOT, that is complementation. When it comes to the OR operator, it will going to perform logical addition. Then which symbol we are going to use in order to represent this logical operator called OR operator? That is plus. So if I am using x plus a y, then how can I read this? X or y. So that plus is nothing but we are going to do the logical addition. So here you can see the truth table as well as the Venn diagram for this OR operator. So we are taking two variables x and y, 0011, 0101 is my input here. Addition in the sense we have to add. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, is it 2? No, because we are dealing with only zeros and ones, it must be 1. So 1 plus 1 is 1 here. So here you can see the Venn diagram of this OR operator. So it will going to take the values both from x as well as y and it will going to perform the addition operation. Next we'll see the AND operator. This is also binary operator. It will also going to be operates on two variables. But what kind of operation it is doing? So it is doing logical multiplication. And which symbol we are going to use? That is dot or a product symbol. That is dot. Okay, so we are going to use a logical symbol or logical multiplication dot. If I write x dot y, how can I read this? It can be read as x and y. What is the truth table for this? We are going to do the multiplication. So I am taking two values x and y. X dot y will be my output. So here 0 into 0, 0, 1 into 0, 0, 1 into 0, 0 and 1 into 1 will be 1. Then what is the Venn diagram here? X, Y. So we both, when the inputs are common, both are in X and Y, that will going to be used in order to perform the logical multiplication. So this Venn diagram and truth table of all the operator called AND, OR and NOT is important. We'll see the next topic, that is related to what? Evaluation of Boolean expression using truth table. So we are going to evaluate whether it is right or wrong with the help of truth table. We'll see, we have to follow some of the steps in order to have this truth table and based on that we are going to do the evaluation of the Boolean expression. What is the step 1 here? We have to determine the number of variables for n variables which will going to be created on a table with 2 power n rows. That means if I say 2 variables, then how many rows and how many columns should I take? First I have to determine that with the help of this 2 power n. For example, n is nothing but variable here. So if my variables are only 2, so that indicates 2 power 2. So 2 power 2 in the sense 2 into 2. So it will be 4. I need to take 4 rows. Okay, that you have to remember. That is related to what? Step 1. Then how we are going to do that? For 2 variable x and y, then the truth value will be 4 rows. What if it is 2 power 3? At that time, 2 into 2 into 2. So 2 2s are 4, 4 2s are 8. It will be of 8 rows. That we have to understand. Next, in step 2, list the variables and every combination of 1 and zeros for the given variables. First, I have to find out number of variables, and in the second step, we have to write the expression. That means we have to write the variables, like whether it is 0 or 1. So, in that way, we have to write in the step 3, create a new column for each term of the statement or argument. Then make a column of all the variables or make a column for each term of the statement or argument, the expression, whatever they have given as a Boolean expression. Then in the step 4, if two statements have the same truth values, then they are equivalent. So after getting the resultant, if the two columns or the two statements have same value, then that indicates that they are both equal. So we'll see one of the example here. We are dealing with example called x plus y bar. How we are going to do that? Let me show you here. So first we have to, what is the first step? I have to understand the number of variables, isn't it? How many variables I have here? X and y. Those two are the different variables. I got to know that I need to use two variables. So I am going to make 2 power 2. That means I must have a 4 rows in my truth table. What are the variables I have? X and y. But here you can see the question or expression, that is x plus y bar. I'm just going to deal with x and y. What do you mean by this y bar then, or y complement? That is logical not. I have to change the value of all the y to its complement. Okay, so that here x, y, and I'm going to create one more column called y bar. So how I'm going to write the values? 0, 0, 1, 1, 0, 1, 0, 1. So y complement in the sense what? Whether input is 0, output will be 1. If it is 1, output will be 0. So here 0 become 1, 1 become 0, 0 become 1, 1 become 0. So now what is the final expression that I wanted to get? That is x plus y bar. How I am going to do that then? X will going to be added with y bar. So if I am performing addition, when both the inputs are 0, it will be 0. If both the inputs are 1, it will be 1. If any one of the input is high or true, then that will be 1. So that 0 plus 1, 1. Then 0 plus 0, 0. So 1 plus 1, 1. So 1 plus 0, it will be 1. This is how we are going to get the resultant. That is what we are evaluating a Boolean expression with the help of this truth table. These are the steps we have to follow. So here you can see some of the example which I have given in order to create or in order to build a truth table by a combination of a following Boolean algebra expression. Let me consider this first one. What I have there? X bar, y bar plus x bar, y. So how many variables I have here? Only 2, which are those x and y, right? So after that, I need to take a complement of x as well as y bar. Let me consider the values here. 0, 0, 1, 1, 0, 1, 0, 1 here. So after this, we just need to complement this x. So 1, 1, 0 it will become, and it will become 1, 0, 1, 0. So after that, what is the first expression I have here? X bar plus x bar, y bar. That indicates we have a product. So that means I need to multiply. 1 into 1, 1, 1 into 0, 0, 0 into 1, 0, 0 into 0, 0. Then I am going to find the value of x bar, y. So if nothing is in between, then that is considered as multiplication here. X bar, y. So this is x bar, this is y. I just need to product. So 1 into 0, 0. 1 into 1, 1. 0 into 0, 0. And 1 into 0, 0. This is related to x bar, y. Then what is the operator that I have here? Addition. So I just wanted to take that. Let me consider it as z. That is the complete value. So we have to add these two values. So it will be 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0, and 0 plus 0 will be 0. This is the truth table we are going to generate in order to evaluate this expression called x bar, y bar plus x bar, y. So these are the steps we have to follow when we wanted to write this Boolean expression with the help of truth table. I hope you all understood. Let me move to the next topic, that is related to logic gate. So as I told, logic gates are used in order to build a circuit. Then what is this gate is all about? So it is an electronic circuit which will going to operate on one or more input signal and always produces an output signal. It will operate on one or more input signal, but it will produces the output signal always, which is based on the input signal and kind of logic gate that we are going to use. So here also it has three kinds of logic gate. It includes NOT gate, OR gate as well as AND gate. Already we know how this operator will going to do, right? So NOT gate is nothing but what? Complementation. So this OR gate is related to addition. This AND gate is related to multiplication or a product. We'll see about the first type, that is related to NOT gate. So here we have to talk in the terms of gate. So that means it will going to operate on a input signal and output signal. So NOT gate is also a gate which will going to have only one input signal and only one output signal. So if I am going to talking with respect to variables, it will going to deal with only one variable. But when I am talking about this NOT gate, so this will going to take only one input signal and produces only one output signal. So the output state is always complement or opposite of the input signal. So this NOT gate is also considered as a inverter gate. Very, very important question. Which gate is also considered as inverter gate? That is NOT gate, because output is not at all same as the input. Okay. So that the output is sometimes called as the complement or opposite of the input. Then how we are going to write the logical symbol and truth table for this? This is the logic gate. So if my input is X, then the output will be its complement. If my input is A, then the output will be A bar or A complement. This is what? NOT gate. Then how about this truth table? X and X bar. As we told, it will going to deal only with single signal. So 0 become 1, 1 become 0. We'll see about the next type, that is related to OR gate. So it will also going to deal with two or more input signal, but it is all going to produces only one output signal. So when it will produce output as a 1, then if any one of the input signal is high, then the output will be high, because we are performing Boolean addition. So if any of the input signal is high, then the output will be high for this OR gate. So here you can see the logical symbol. This is how we are going to write the logical symbol of OR gate. So it will take two input called X and Y, and we are going to write a symbol. What it will going to produce? X plus Y as a resultant. So if it is of 3 input, how I am going to write then? Let me consider I have X, Y and Z. So these are my input. Then how I am going to write? X plus Y plus Z. This is the 3 input OR gate. And also we have a truth table for here. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. What we have learned here. So if any one of the input signal is high, the output will be high. Same thing happened with this addition. And also we have a 3 input OR gate here. All become 1 when we have any one of the input signal is high. So if all the signals are low, then only the output will be low. We'll see the last one, that is related to AND gate. So this is also going to take, or it will going to deal with 2 or more input signal, but generates only one output signal. When the output will be 1 here. So when all the input signals are high, then the output will be high in the AND gate. Otherwise it will be 0 or low or false. So we'll see the logical symbol. So for this 2 input AND gate, the logical symbol will be like this. So it will going to take 2 inputs like Y, X and Y. The output will be X dot Y. Then how we are going to write the truth table? X and Y. So we have a X dot Y. So if any one of the input signal is low, then the output will be low. If all the input signals are high, then only the output will be high. Same thing with this 3 input AND gate. It's all about today's session. I hope you all understood. Let me meet you in the next session with a continuation of this chapter. Until that, keep learning, keep on growing. Thank you.